This is the Vespera Pro from Vaonis. It doesn't have any eyepiece, you can't really manually control or even focus it, and it does about 90% of the work for you. For some experienced astronomers, that sounds like a nightmare. For everyone else, well, it might sound like magic. We are looking at a polarized market right now. There is a hate it or love it relationship with these all-in-one units, but after spending time with the Vespera Pro, one thing is undeniable. Smart telescopes are no longer a gimmick, they are here to stay. Does this replace a customized, cooled monochrome camera rig? Definitely not. But does it offer an experience that brings the deep sky to your driveway in 5 minutes flat? Absolutely. Let's find out what the Vespera Pro can actually do, who is it for, and if it's worthy of your attention. To understand this device, you have to understand the company building it. Vaonis is a French startup founded by aerospace engineer Cyril Dupuis with a singular philosophy: friction kills curiosity. He understood that the struggle of setup was keeping people out of the hobby. While a select few endure the cold to get the shot, the masses just want the universe at their fingertips. So Vaonis started building machines to bridge that gap. With the Vespera Pro, their flagship model, they are combining their signature ease of use with some decent specs. So when they got in touch and asked if I would be interested in reviewing the Vespera Pro, I immediately said yes. And while this is very generous of them, I need to make it clear that my opinions are my own and they didn't influence the verdict of this video in any way. So with this out of the way, let's take a deeper look at the Vespera Pro. Unlike your typical telescope, the Vespera Pro arrived in this nice hard case. On the inside you find a telescope, let's put it aside for a moment, tripod legs, and tripod adapter, including a lock pad for securing the telescope at night. Moving over to the telescope. There is no denying that this is a very sleek, very minimalistic piece of hardware. It's also heavy and dense for its size. It really does feel like I'm holding the iPhone equivalent of a conventional astrophotography rig. Another thing the Vespera Pro reminds me of is the aperture sentry turret from the video game called Portal.
I see you.
The housing is completely made out of hard, glossy plastic, which at first glance doesn't necessarily scream top quality, but it's what's on the inside that counts. Here Vaonis used a lot of quality materials for the inside of the Vespera Pro, and I must say it is making a very sturdy impression. The whole telescope is also water resistant, meaning that it shouldn't have any problems dealing with rain or snow. The base of the telescope features a 3/8 of an inch thread for attaching it to the supplied tripod adapter or any other tripod you might have lying around. The supplied tripod base is made out of aluminum, including the attaching telescopic legs and the level plate. But if you are to spend over 2.5K on a telescope, the components on the inside have to be pretty good. If you were to build a traditional compact rig today, you would probably consider something like a Red Cat 51 or similar 50mm apochromatic refractor. You'd pair it with a decent dedicated astro camera, an autofocuser and a guiding camera, and then mount it all on a star tracker, connect it to a battery pack and plug everything into a laptop. The Vespera Pro is essentially that entire rig fused into a single unit. Let's start by looking at the hardware that actually gathers the photons. Well, this isn't a standard doublet or triplet refractor. Vaonis has engineered a dedicated quadruplet apochromatic refractor design. Optically, we are looking at a 50 mm of aperture and a 250 mm focal length, giving you a native f/5 focal ratio. It features 4 lens elements arranged in 2 groups, 2 elements at the front forming the objective and 2 at the back in front of the sensor. According to Vaonis, all lens elements are made out of SFPL52 glass, which is unusual. Normally only one element is low dispersion and the other ones are made of standard optical glass. Nevertheless, the SFPL52 rating should reduce chromatic aberrations or color fringing to a minimum, keeping stars tight and round all the way to the corners. There is also a built-in anti-fogging system. It uses a heating element that works together with a temperature and humidity sensor to activate when necessary. Moving over to the back of the OTA, one of the 2 glass elements located just in front of the sensor is the field corrector, which is responsible for flattening the image and reducing aberrations as much as possible. There is also a built-in UV-IR cut filter with a bandpass from 430 to 680 nanometers to improve image sharpness and color accuracy by allowing only visible light to pass through. Speaking of filters, Vaonis offers a small selection of optional filters for the Vespera lineup, which are nice and are designed for a perfect integration with the telescope. But these aren't your standard 2-inch format filters. The Vespera uses a proprietary format here. Alright, but what about the sensor? Because after all, light is useless if you can't catch it. This is where the Vespera Pro makes its most aggressive technical leap compared to the rest of the lineup by integrating the Sony IMX676 Starvis 2 sensor. This is a well-regarded backside illuminated CMOS sensor with a 1/1.6 inch or 7 by 7 mm square format, delivering 12.5 megapixels. Combined with the optics, it delivers a 1.6 by 1.6 degrees wide native field of view. The pixels are small at just 2 microns, and this combined with a 250 mm lens results in an image scale of 1.65 arc seconds per pixel, which is right in the Goldilocks zone for wide field astrophotography. This means that there is quite a significant amount of oversampling happening, which should make the most out of average seeing conditions. One aspect missing completely here though is that the sensor benefits from passive cooling only. There is no thermoelectric cooler to freeze the sensor to -10 degrees Celsius like dedicated astro cameras. However, the Starvis 2 sensor has a rather low thermal noise, and the Vespera uses a dark frame calibration process to automatically map out hot pixels, which according to their documentation should visibly improve the results in this regard. We'll see if this is the case in the second part of this video. Powering everything is a 10,000 milliamps battery rated for 11 hours of continuous operation. I was able to get about 7 hours of operation time during nights with average ambient temperatures hovering around -3 degrees Celsius. It also supports fast charging over an USB-C port at the bottom. But unfortunately, there is no charger included with the telescope. You will need to get one separately. So from a hardware point of view, the Vespera Pro definitely makes a solid impression. Now let's add in the software layer that ties it all into a complete package. Hardware is only half the battle. In astrophotography, the software is just as important, and unfortunately it's also what usually makes people quit or keeps them away in the first place. If you are an experienced astronomer, then you are used to the driver dance. Downloading ASCOM platforms, troubleshooting USB dropouts, and configuring Nina or ASIR. It is a powerful, fully flexible setup when it works, no question. But getting there is not always easy. The Vespera Pro runs on Singularity, and sticking to my Apple analogy from earlier, it's the iOS of astrophotography. It allows you to select targets, configure your observing sessions, control some aspects of the camera, and of course, it is the place where you can view the final results. The app is comprehensive and intuitive to use. It's also completely free and available for iOS and Android. But before I bore you with software capabilities, let's put everything, hardware and software, to the test and see how the Vespera Pro actually performs under real conditions. Coming from an entry-level custom rig built around an ASCAR 71F and an SV705C camera on an on-step powered EQ5 mount, I was genuinely curious to see if a smart telescope like the Vespera Pro can actually keep up with a traditional setup. To find out, I've been testing the Vespera Pro for about a month now on nights with good seeing conditions from my backyard under bottle 4 skies. One of the first aspects I came to appreciate was how easy the setup can be. In most cases, I got outside, placed the telescope on the ground, turned it on, removed the dust cap, and immediately went back inside. Everything else that followed could be done from the comfort of my home. Pairing the telescope with my phone and starting the initialization sequence worked pretty much flawlessly, except for the first time I tried it out. Because the Vespera relies on plate solving to orient itself, it cannot distinguish between a cloudy sky and a physical obstacle like a tall fence or the roof of your house. If its line of sight is blocked during initialization, the software can get confused. Instead of throwing an obstruction detected error, it may incorrectly calculate its position, resulting in a failed imaging run without telling you why. This was therefore a bit tricky to troubleshoot. But once I understood what was going on, the fix for this was easy. When setting the telescope on the ground and manually opening the arm, you only need to make sure that the telescope is pointing into a direction free of obstacles. Simple as that. If that first alignment image is correct, then the rest of the initialization process works reliably and without a problem. Troubleshooting this would be much easier if the app would feature any kind of live feed from the camera to be able to see what the telescope actually sees. Maybe this can be added later on with an update. After the initialization process, you are invited to choose a target from a selection of targets currently visible from your location. You can, however, search for any targets you wish. Here I like to use Stellarium beforehand to browse the night sky to get a better visualization of the objects available for photographing in the direction that is free of obstacles. Then I simply input the target's name into Singularity and hit start. From here, the telescope takes care of everything: slewing, framing, capturing, continuous focusing, all while performing live stacking. If you are confident that the seeing conditions will hold throughout the night, then adding other targets to the plan is only one tap away. I tried this out and it worked flawlessly. After finishing the plan, the telescope started with M31 for 2 hours, then slewed to M45 for another 1.5 hours, after which it parked itself and went to sleep before sunrise. Another interesting aspect with a lot of potential is the advertised ability to create mosaics, significantly increasing the captured area of the night sky. Called Coval ENS, it allowed me to capture the whole M31 instead of just the galactic center. As you can see, the mosaic functionality not only worked, it completely surpassed my expectations. If we examine the final 50 megapixel image, there is no trace of misalignment where the mosaic got stitched together. And the best part is that it's doing all in real time for you to check out on the screen of your phone. Very impressive. Another massive pro is the session continuity, which allows you to pick up the session where you left off the last time. This can be a lifesaver if clouds roll in or the battery dies. In these cases, the app remembers exactly how much data you gathered, so you can come back a week or 2 weeks later, press one button, and it will flawlessly align and continue adding photons to the exact same stack. This is made possible by a proprietary technology called Preserver ENS, and I tested this feature by capturing 1.5 hours of data on the Pleiades before ending the night. When I set up the unit again a week later, the software automatically synced with the previous session. It realigned to the correct coordinates and immediately began adding new data to the original stack, making multi-night integration effortless. And then there is one of Vespera's Pro party tricks, the universal master dark. Instead of taking dark frames every single night, the Vespera Pro builds a master dark library once. It measures the sensor's thermal noise pattern and automatically subtracts it from your images based on the current temperature, and this is a massive quality of life feature. Where in the past, smart telescopes were mere JPEG toys, the Vespera Pro opens the back door, meaning that you aren't stuck with pretty images on your phone. You can pull 16-bit FITs or TIFF files directly from the telescope's internal 225GB SSD, which by the way offers enough storage for a few full nights of capturing. In expert mode, you can also override the auto exposure. So if you know that a 10-second exposure is going to blow out the object you want to capture, you can manually drop it to 4 seconds. You can also adjust the gain to lower the noise floor manually. So where do we land? Hate it or love it? First, I want to address the veterans, the astronomers who have been using their own custom rigs for years. I'm only relatively new to astrophotography, having only started a couple of years ago, but I understand that there is an undeniable art to manual astrophotography. Selecting the right back focus, balancing the counterweights, dialing in the focuser, and mastering post-processing is a skill. It is a craft, and nothing takes away from the pride of building an image from scratch. But let's be honest with ourselves, it's also a lot of friction. It is heavy lifting, alignment and adjustments, driver updates and freezing cold nights, troubleshooting while the guiding graph is spiking. That friction is, in my humble opinion, the #1 reason people keep away from this hobby. This brings me to the biggest criticism I hear: using a smart telescope is cheating. And I completely disagree. The Vespera Pro isn't cheating, it's simply shifting the focus. It moves the goalpost from mastering the equipment to enjoying the universe. It removes the barrier between you and the stars. And for people that are either completely new to this hobby or the ones that don't necessarily have the time to spend night after night outside skipping sleep, smart telescopes like these make a lot of sense. And then there is the issue of the price. While 2.5K sounds like a lot at first glance, it actually isn't. If you were to build up a custom rig with similar specifications, it would likely cost you just as much, if not more. However, before I tell you to run out and buy one, we need to talk about the downsides, because the Vespera Pro is definitely not perfect. For example, unlike my ASCAR setup, there is no upgrade path. You can't swap the camera for a better one. You can't upgrade the OTA for a better one, or change the focal length if you want to zoom in on a planet. You are marrying this specific ecosystem. If the internal battery eventually degrades, or if the electronics fail, the whole unit is down. Then there is the focal length limit. You are locked at 250 millimeters. That is great for wide DSOs like the Andromeda galaxies or the Pleiades, but if you want to see the rings of Saturn or the Great Red Spot on Jupiter, this is the wrong tool. It is a wide field specialist, not a do-it-all telescope. I expected to find a toy for beginners. What I found was a serious instrument that I genuinely enjoyed using. Smart telescopes are here to stay, and if they help more people look up and appreciate the cosmos, then I say let the robots help us explore. Anyway, that's been it. I hope you all enjoyed it. Let me know what you think about the Vespera Pro and about smart telescopes in general. I'm very much looking forward to reading your opinions in the comments below. Thanks for watching and catch you guys in the next one.